On this week's Cumulus on Cloud, we're going to talk about how networks affect your move and transition to cloud. When a company first starts thinking about moving into a cloud environment, often one of the things that comes up is how are we going to deal with our end users getting access to the resources that we now push into a different location. Now, moving servers off of your own data center, off of your own networks even, isn't all that new. People have been doing it in co-location facilities for years. Often, though, in a co-location facility, if you're big enough, your organization is big enough, you've already created some form of direct connection into that location. And in fact, your co-located facilities, your co-located data center is on your network. That might be through something like an MPLS technology, or more likely through a VPN and a VPN concentrator environment. And in reality, these things don't have to dramatically change. Many of the VPN services have cloud-based VPN endpoints so that you can use those resources to attach your network into the public cloud. It certainly is a viable option. It follows the tried and true processes that most enterprises already have. And I think for most, at least as an initial step, it's probably the right path into that space. In addition, most enterprises that have had any kind of internet presence, even if it's only outbound presence, will still have some form of firewall protecting their resources as well. Whether that, again, being in a co-location facility in their own data center or some other way distributed through a set of resources, that firewall provides another layer of protection. And again, we have the same model here where we can continue to use those firewall services that we've used in the past, but use them in a cloud form, in a network function form. In fact, there's a whole sort of explosion of a new sub-industry in the network space known as the network function virtualization space, or the network virtual function space. I've seen it sort of both ways, so either NFV or NVFs. So people talk about virtualized network functions, VNFs. But all of those sort of three-letter acronyms that you can sort of spin around a bunch of different ways, all really sort of imply the same thing. We're taking these static, or actually now more likely dynamically configured resources, we're placing them in some kind of a virtual container. Often this is a virtual machine-based process, but we're placing them into a virtualized domain, getting the same general sets of functions, but there is the potential for a performance impact. Now, there are a number of ways of dealing with that performance impact, including things like looking at just scaling up the number of resources that are available. If we go back 10 or 15 years, often the way that you scaled was the way we classically scaled compute. Get a bigger machine. You know, have a small little machine if you have a small load, and a really big machine if you have a big load, and that was sort of how we dealt with it. As we got to sort of the hyperscale cloud native-like applications, where we might have thousands of front-end resources and potentially be sort of saturating a 10 gigabit link into that environment, those firewalls started having trouble keeping up. The VPN services would have trouble keeping up at those sorts of rates. And so instead what happened was the developers of the firewall and VPN services started to expand their mindset and say, well, we can deal with session state, which is usually the big problem. How do I know that this same transit of traffic is coming from the same source and destination? How can I keep that session state pinned to a particular instance of a firewall or a VPN endpoint so that I can keep the communication consistent and not have to constantly re-authenticate or reconnect back to the service at the end? So a lot of work has gone into those sorts of scale points, and now we do see the ability to scale your VPN concentrator environment, your VPN function environment, or your firewall environment in an appropriate fashion. And that's, I think, one approach to getting your resources into the cloud is just to use these virtual functions. Many service providers can provide them embedded for you so that you don't even have to deal with them yourself, which is, again, sort of moving towards that. IT is no longer focusing on operating the individual resources, but rather focusing on operating the system as a whole. So keeping track of how their firewall functions are working, keeping track of what kinds of errors and attacks are coming into the system. Are there things that should be mitigated? Are there other ways of approaching how you actually run your applications to improve the performance of the system? Now, of course, if your application is an open front end of some nature, potentially your customers have a customer service portal, or maybe you're a software as a service vendor, often you're starting to think about security in a slightly different way. You're thinking more about how the application is securing itself rather than how the network service itself is securing itself. And there are some benefits and advantages and potentially even some disadvantages of doing this. For one, your attack surface is now your web front end. That's where the attackers are going to try to focus their efforts. And we really have to think about networks and network services really from the perspective of network security. But now application security becomes a core part of that as well. We'll talk about security in another session, but security always comes up in any of these sorts of domains. How do I deal with this, especially once I have things that touch that internet interface? There's just so much going on in the world today that we really have to think about this as one of those first and foremost steps. But when we think again about the network and we think about those network technologies, we're thinking about either I would say old school, but in a new light. So automated, dynamic, scalable, older models where I'm thinking about static firewalls, where I'm thinking about static VPN concentration tools, or I start moving into how can my application actually become more secure so that I can provide access to anybody who has credentials or who can authenticate themselves appropriately, but without having to establish a lot of precursor work in doing that. In other words, how can I automate even the authentication processes? And we see this coming together in some of the cloud native space specifically. So again, virtual functions I think work really well if you're just transitioning, basically lift and shift type models of moving things into the cloud. If we can get into cloud native models or move our old applications into these cloud native spaces, whether we fully microservice something or just start managing and thinking about how we integrate and interact with those services in a more modern API-enabled approach, we can start making use of tools like the service mesh tools, which are an important part of the microservices application strategy. But I think they're appropriate for things other than microservices. I think we can start looking at how the network and the microservices network model can be applied to even classic applications. The real key is enabling the interface into the application to be dynamic and to have controls that are now dynamic. And the way we do that in most cases was sort of led by the concept of a sidecar application in the Kubernetes space. Now, we're not going to get too deeply into Kubernetes today, but just think of a sidecar as an application that gets spun up in conjunction with your main app. So if you have automation, as we all should, to deploy our applications, one of the things that automation would do is to establish, for example, a proxy in front of our application so that we can control the proxy for security, for forwarding, for authentication purposes, and our application team can focus on making sure the application is doing the right thing rather than having to deal with that authentication service. In the microservices space, this got really important, or is really important, because I might be using multiple different languages for different parts of my application, and being able to ensure that the communication between those applications is secure often meant finding a library that would work between those different application types. So a library that would work in a Java space and a Node.js space to provide that mutual authentication, as an example. So the microservices tools can provide that mutual authentication to potentially any service because they're acting as a proxy for the communication. Now, I say any service, but there are some that we have to be aware of. So in the networking space, there are session-based protocols. The most common is the TCP stack, which often runs on top, well, it is a part of the IP Internet Protocol environment. So that's one model for communicating across an IP network. The other is the UDP, or datagram process, where we don't have sessions. And the difference is that with a session, you can actually do things like understand session establishment and session lifecycle. With datagrams, the packet-based model, while everything is packetized, we don't really have that session model to really work with. There's some things that we can do to enable that or to sort of leverage that concept, but it's a little bit different approach. And so most of the service mesh technologies today focus on that session-based model, the TCP-based model, versus the UDP-based model. So if your application is UDP-based, we have to figure out other ways to leverage the models behind the service mesh technologies to really enable those networks. But I really think that what service mesh is doing doing, and especially what a tool like Istio, which is I think one of the premier ones, Linkerd being the other one that still comes up quite a bit. Probably more people have deployed Linkerd than Istio, but Istio is the new shiny version, and Linkerd is now the slightly more dated version. But both of these technologies have the same general constructs in terms of mutual authentication of resources. And I think that's where network and network security come together for cloud native applications, where they can make use of these tools directly. And even for older applications, I think we can start integrating these application services into the space. But we have to think a little bit more about it. In the cloud native space with Kubernetes, we can automate the creation and connection and establishment of all these resources. If I'm using this with maybe a legacy application or a slightly older application that isn't yet microservices and Kubernetes and containerized, I have to think about how I'm going to establish connections in that Istio domain. And it just requires a little bit more work to actually add that into the application deployment and or delivery automation. So it's something to think about. But when we think about the big picture, again, moving from a private environment, even a co-located environment, into the public cloud might not be a huge shift. It might just be maybe a slight change in how you're interacting with and managing the resources within that system space. How are you actually managing those network functions and services versus how are you actually using the network at all? And at the extreme end of that, sort of the cloud native space, we now have the service mesh concept and the embedded authentication and authorization that comes along with that, which I think can address many of, if not, well, I wouldn't say any one thing ever addresses all, but I think it can address many of the concerns that people have about how to move their applications into that space and yet give their end users, whether they be customers or internal users, access to those services in a secure fashion, especially as the local network itself may also go away. If we move to work from home type models, do we necessarily want to have VPN concentrators everywhere and distributed across the world? Or do we just want to mutually authenticate the end user resource? So I think we're seeing more and more of a shift towards automating as many of these processes, removing the overhead and burden of having the right software in place in order to make these things work, dealing with software updates and all the other things that come along with that. If we can automate those processes more, we get much more efficient environments. And I think the network is one of those environments where we've seen such a dramatic shift from hardware everything to now software everything and centrally controlled software everything that really it's a huge lift into a more modern approach. And the best part is that we can apply many of those technologies to the older applications that we're still moving into cloud-based environments. Well, folks, thanks for watching. If you liked it, don't forget to like it. Hit that thumbs up button. We always like to know that we're doing a good job. Don't forget to share this with your friends, and just to make sure that you get the latest and greatest episodes that we release, hit that subscribe button, and don't forget to hit the little bell next to it so that you actually can get notified when they come out. Thanks so much for joining us.